Democracy, at its heart, is a system of government where power resides with the people. It sounds straightforward. The idea is that every individual has a voice, and through a collective process, these voices shape the direction of society. This concept is both empowering and inspiring, suggesting a world where everyone has a say in the decisions that affect their lives. People should be able to express their preferences. This is done through the act of voting, a fundamental right in democratic societies. Voting is the mechanism by which individual opinions are collected and counted. They do this through voting. Each vote represents a person's choice, their voice in the democratic process. It's a simple act with profound implications. The system then translates these individual choices into collective decisions. This is where the complexity begins. How do we ensure that the aggregation of these votes truly reflects the collective will? But herein lies the rub. How do we ensure that the collective decision truly reflects the will of the people? It's a question that has challenged societies for centuries. This question, seemingly simple, has perplexed thinkers for centuries. Philosophers, political scientists, and mathematicians have all grappled with this issue, each bringing their own perspectives and solutions. The answer, it turns out, is far from simple. The process of translating individual preferences into a collective decision involves numerous variables and potential pitfalls. The challenge of democracy lies in finding a system that accurately aggregates individual preferences into a collective choice. Different voting systems have been proposed and implemented, each with its own strengths and weaknesses. Imagine a group of friends trying to decide on a movie. Some might prefer action, others comedy, and yet others science fiction. This simple scenario mirrors the complexities of democratic decision-making on a larger scale, and yet others science fiction. Each preference is valid, but how do we decide which movie to watch? How do we ensure that the final choice reflects the will of the group rather than the dominance of a particular preference, or worse, manipulation of the system? This is a microcosm of the larger democratic challenge. This is where mathematics enters the picture. Mathematical models can help us understand and analyze different voting systems, providing insights into their fairness and effectiveness. We can use mathematical models to analyze different voting systems. These models allow us to simulate various scenarios and see how well each system captures the will of the people. We can see how well they capture the will of the people. By examining the data, we can identify patterns and potential issues that might not be immediately apparent. These models reveal some startling insights. They show us that even systems designed with the best intentions can have flaws and unintended consequences. They demonstrate that achieving a perfectly fair and representative democracy might be mathematically impossible. This realization forces us to confront the limitations of our current systems and consider new approaches. This essay delves into some of these mathematical challenges. It examines the intricacies of different voting systems and the paradoxes that arise from them. It explores their implications for our understanding of democracy. By understanding these challenges, we can work towards creating more robust and fair systems. Let's embark on this journey to understand why something as fundamental as democracy faces such profound mathematical hurdles. Together, we can explore the complexities and strive for a better understanding of how to make democracy work for everyone. For centuries, mathematicians and political scientists have been on a quest. This quest is not just an academic exercise. It is a pursuit that has real-world implications for how societies are governed and how power is distributed. They've searched for the perfect voting system, a system that could seamlessly translate the diverse preferences of a population into a decision that everyone can accept as fair and just. The system would take individual preferences and transform them into a collective choice. The idea is to create a mechanism that respects each person's voice while synthesizing these voices into a coherent outcome. This choice would need to be fair and representative. It should reflect the true will of the people, ensuring that the majority's preference is honored while also considering minority opinions. One might think this task is easy. After all, in its simplest form, voting is just a matter of counting preferences. But the reality is far more complex. We could just have everyone vote for their top choice. This seems like a straightforward solution, but it doesn't always lead to the most representative outcome. Then, we could pick the option with the most votes. This method, known as first past the post, is widely used but has significant drawbacks. This system, known as first past the post, seems straightforward. It is simple to understand and easy to implement, which is why it is so popular. However, it suffers from a major flaw. It can result in a candidate winning without a true majority, leading to questions about the legitimacy of the outcome. It can lead to situations where a candidate wins with a significant portion of the population opposed. Consider this scenario. Imagine an election with 3 candidates. 3 candidates are running for office. Each has a distinct platform and a dedicated group of supporters. Candidate A receives 40% of the vote. This is a significant portion, but it is not a majority. Candidate B receives 35%. Close, but not enough to win. Candidate C gets 25%. The least of the 3, but still a substantial number of votes. Candidate A wins, even though 60% of the voters preferred someone else. This outcome can feel deeply unsatisfactory to the majority of voters. This outcome hardly seems representative of the will of the people. It raises questions about the fairness and effectiveness of the voting system. This problem highlights the need for more nuanced voting systems. Systems that can better capture the complexities of voter preferences. We need systems that can account for the intensity of preferences. Systems that can weigh not just the top choice, but the full spectrum of voter opinions. They need to consider the ranking of choices, not just the top pick. This is where alternative voting methods come into play. This is where systems like ranked choice voting come into play, where voters rank candidates in order of preference. This method aims to ensure that the winning candidate has broader support. However, even these seemingly more sophisticated systems are not without their flaws. They can be complex to understand and implement, and they don't always produce perfect results. As we'll see, mathematical theorems like Arrow's Impossibility theorem demonstrate that there might not be a perfect system after all. This theorem shows that no voting system can perfectly translate individual preferences into a collective decision without some form of compromise. In 1951, a young economist named Kenneth Arrow dropped a bombshell on the world of political science and mathematics. His discovery, now known as Arrow's Impossibility theorem, sent shockwaves through our understanding of democracy. What Arrow proved, mathematically, was that no voting system can simultaneously satisfy a set of seemingly reasonable fairness criteria. Imagine a group of friends trying to decide on a restaurant. They want a system that's fair to everyone. Arrow's theorem states that no matter how they design their voting system, they will inevitably run into a situation where at least one of these fairness criteria is violated. This theorem isn't just a theoretical abstraction. It has profound implications for the way we think about democracy. It suggests that there might not be a single best voting system. Every system will have its own strengths and weaknesses. To fully grasp the significance of Arrow's theorem, we need to understand the fairness criteria he proposed. These criteria, seemingly straightforward, become surprisingly difficult to satisfy simultaneously. Arrow's Impossibility theorem rests on a set of fairness criteria that any reasonable voting system should strive to meet. These criteria are designed to ensure that the system is fair, logical, and democratic. However, as we will see, meeting all these criteria simultaneously is a challenging, if not impossible, task. Let's break them down in simple terms to understand why they are so important and why they are so difficult to achieve all at once. Unanimity. If everyone prefers option A to option B, the voting system should choose A over B. This criterion seems obvious and straightforward. It ensures that the collective will of the people is respected. If everyone agrees, the system should reflect that agreement. This is fundamental to the concept of fairness in any decision-making process. Non-dictatorship. The system shouldn't be controlled by the preferences of a single individual. In a fair voting system, no one person's vote should have the power to override the collective decision of the group. In a democracy, no one person's vote should outweigh the combined will of others. This ensures that the system is truly representative of the people's preferences. Independence of irrelevant alternatives. The ranking of A and B shouldn't be affected by how people feel about a third option, C. This criterion ensures that the introduction of an irrelevant alternative doesn't skew the results. For example, if we're choosing between pizza and tacos, it shouldn't matter how people feel about sushi. The presence of sushi as an option should not influence the choice between pizza and tacos. Transitivity. If the system prefers A to B and B to C, it should also prefer A to C. This criterion ensures logical consistency in the collective preference, making the decision-making process coherent and rational. This criterion ensures logical consistency in the collective preference. Without transitivity, the system could produce contradictory and confusing results. Arrow's theorem demonstrates that it's mathematically impossible to create a voting system that always satisfies all four of these criteria. This paradox highlights the inherent complexities and limitations in designing a perfect voting system. This means that any system we design will have some inherent flaws or limitations. Understanding these limitations is crucial for improving our voting systems and striving towards greater fairness and representation.